So welcome to our first class, chapter 1, which is displaying descriptive statistics. Now, when we are looking at chapter 1 of this study, the main objectives are basically to teach you how to explain data, displaying it into the pictograms that we by now should well know. We have different types of pictograms. We have what we call a bar chart, which are spaces. We have what we call a histogram, which does not have spaces. Can be done like this, or you can put one dot there. This is also a type of a histogram, which looks like a bar chart, but it's actually a histogram, which already has demarcations that are being shown like that. The other pictograms you need to be aware of are the ogive. It cuts a midpoint of the histogram. We also have other pictograms that you need to know, like the pie chart. Simply looks like this. Okay. It has pies like this. We also later on look at a pictogram, which looks like this. It's got a box whisker plot. Helps us to depict an outlier, if any. We're also going to look at other pictograms, which are called the stem and leaf diagram. 1, 2, 3, 4, 5. Figures are in ascending order. So this is a stem and leaf diagram. We have 12, 13, there's no 20s there, there's 35, 37, 37, and 42. So this is what we call a stem and leaf diagram. We'll also look at what is called the frequency distribution table. It has classes, for instance, 1 to 5, 6 to 10, 11 to 15. And we have frequencies like 4, 9, 3. This is a frequency, and the cumulative frequency is an add-on. You bring the 4 there, you add it to the 9, you get a 13 there, you add it to the 3, you get a 16. So this is called a frequency distribution polygon. Right? Quickly, let's do a quick, can you remember? What is diagram 1, 2, 3? What are these? 4, 5, and 6. One, 2, 3, Jeremiah. 4, 5, 6. Messi, what are these polygons?
One is bar chart, the second one histogram. I don't know what you mentioned about number 3, whether it's a histogram or not. Yeah, but the fourth one is an ogive. Then 5th pie chart, and 6th is whisker box and whisker plot.
Number 3 is also a histogram. It's another way of presenting this information. Messi, what do we have on 8, 9?
8, 9, that's stem and leaf. Then 9, that's a cumulative frequency table.
Mm-hmm.
Yeah.
10.
On what? 10. 10.
10. Mm-hmm.
I've forgotten this one, but I think I know it.
It's a tree diagram.
Trigger. Okay.
Yes, it's a tree diagram in probability. So these, you'll find them. You need to understand these pictograms because we're going to use a number of them. All right. So I'll take you to basics of chapter 1, where we're going to understand what we call quantitative and qualitative data. In your final stage, you're going to look at two types of research: quantitative and qualitative research at Masters GBS 700A, GBS 700B. Okay, so what is qualitative and quantitative data?
Quantitative is numerical data. Then qualitative is non-numeric.
Okay. Quantitative is numeric data, whereas qualitative is non-numeric data. So any examples of both of what you mentioned? That's very true. So we need to start from the basics and understanding. So when you're dealing with qualitative data, we're basically looking at information that can be quantified or counted and expressed in terms of numbers. Qualitative, on the other hand, looks at descriptive data that can be expressed in terms of language rather than numerical values. So quantitative is based on quantity. Qualitative is based on quality. And qualitative basically looks at the whys, the hows. All right. So under quantitative, we have two main categories that we are going to subdivide it into. Okay, so let's delve into quantitative data specifically. Let's delve into quantitative data specifically. So this is very vital for you to understand, not only for this course, but for research purposes as well. So when we're dealing with quantitative data, we have to understand that we're looking at numbers in this case. Quantitative variables will tell you how many, how much, how often. And examples would be how many people attended a seminar, or how much revenue you made last year, or how many customers, what range of values would they be comfortable with in terms of paying tuition. We're looking at quantitative information. Now, this quantitative data could be subcategorized into what we call discrete and continuous. So the discrete looks at numbers that are non-integer. So we're looking at numbers 1, 2, 3, 4. These are countable values. This can talk about the number of people born per day. And continuous looks at integer data, which can have what? A scale, 1.2, 1.3, negative 1.5. Okay, so examples of continuous data could be weight, could be age, could be height, all right, could be volumes of water. And quantitative data could be number of times what? Attend a class, number of teachers you have, a number of lectures you have. So these are the whole number of children that you have. So this is what quantitative and yet discrete or continuous. Are we together? This is quantitative and yet discrete or continuous. On the other hand, when we're dealing with another phase of data, we could be talking about information that we can't measure. We may use a Likert scale to collect this data, and this data is called qualitative data. In qualitative data, information cannot be measured. We just want to look at the words and labels that will help us describe the characteristics and the traits. So you would want to turn qualitative data into a why or how So such questions, when you're developing a questionnaire, would allow you to express your own feelings when you want to express, instead of saying yes, no, or you give them a string within which they could express themselves. So like quantitative, we also have discrete and continuous, which has a special name. So here we have nominal data. So nominal data is discrete, kind of. For instance, where are you born? Born either in Zambia or in Zimbabwe. You have one of those. But we also have ordinal data, which can be intersecting. It's like continuous. For instance, what tribe are you? You could hear people say, I'm Lozi, Tonga, Bemba, Punda, because there's an intersecting part. You're a mixed race, you're colored. That's nominal data. All right. So you basically need to differentiate this type of information when you are doing your data analysis. Now, we talked about coming up with what we call a frequency distribution table. This helps us.
Collins,
Yes, please.
yeah, just repeat on nominal and ordinal in terms of this description, apart from discrete and continuous. What did you say?
That it's easy to distinguish ordinal in the sense that it is intersecting. It can have two characteristics in one.
Okay.
Okay, like Bemba, Tonga. But for nominal, you can't be born in Zambia and America at the same time. Okay.
Okay.
So I'm just trying to break it down in a layman's language so that you're able to understand. Any
Okay,
questions so
thanks.
far? Any other questions? Okay, so nominal data has categories or groups with no ranking. So this is data which is qualitative in nature. Those of you who have done research at your undergraduates, you will discover that in the SPSS that you use to analyze, you'll be asked to succinctly stipulate what type of information you are, and also what scale you're using, all right? So when you're dealing with nominal, we're looking at categories or groups with no inherent order or ranking. This data in nature is used to label or classify distinctive groups. For instance, gender, whether male or female, colors, blue, red, green, types of dogs, cat. You've seen that information when you're filling in questionnaires. So that information, which has clear distinctions, is called what? Nominal data. So we also have ordinal data, which also represents a category of qualitative information, but there's no clear ranking amongst them. This kind of data is qualitative, but has a meaningful sequence of hierarchy. So we use a Likert scale to measure such type of data. So instead of saying yes or no, you have strongly agree, neutral. So you have to know the degree of agreeableness or disagreeableness. For instance, even in levels of education, okay, I have a degree, master's degree, okay, social economic status is middle income, high income, low income. So this tendency has a spread within themselves. All right, so we now go to frequency summarizing. So we may be given data that requires us to classify. For instance, we have a demand for hammers at a certain hardware running for 20 days. So we are asked to come up with a frequency distribution table. So if the spread of the data is not so much, we're just going to identify the variables that we are in question trying to analyze. For instance, variables will range from 0, 1, 2, 3, and 4. These ones have a smaller spread. As how many zeros do we have? We count them. 1, 2, 3, 4. So the frequency for this one will be what? 4. Right? Then you go, how many ones do we have? We have 1, 2. Then you put your 2 there. How many 2s do we have? We have 7. 1, 2, 3, 4, 5, 6, 7. Put your 7 there. How many 3s do we have? 1, 2, 3, 4. Put your 4 there. How many 4s do we have? We have nothing here, nothing there. 1, 2, 3. I have a 3 there. Then you total them up. That is our frequency. Cumulative frequency is adding on. So the 4 here can come. You add on to that. Get a 6. Add to the 7. We get a 13. Add to the 4. We get a 17. Add 3. We get a 20. So this is the cumulative frequency graph. Are we following? Relative means subject to the total. So 4 out of 20 is relative frequency, which is 0.2. 2 out of 20, 0.1. 7 out of 20, 0.35. 4 out of 20, 0.2. 3 out of 20, 0.15. So we're just subjecting the totals over the grand total. About relative cumulative frequency, you'll be dividing or adding. You will divide 4 divided by 20, 0.2. 6 divided by 20, 0.3. 13 divided by 20, 0.65. 17 divided by 20, 0.85. It's 0.85, something like that. 0.85. Then 20 out of 20, 1.00. The last number should be 100%. If you want, you can add on these ones there. 0.2, you add the 0.1, we get 0.3, which we had here. Add 0.35, we get 0.65. Add 0.2, 0.85, add 0.15. It's another way of filling up. So frequency, when you divide them by the total, we get the relative frequency. The relative frequency don't necessarily need to be increasing. They fluctuate. So you call it a frequency polygon. They fluctuate. And when you add these frequencies together, the 20 plus 0.10, 0.3. 0.3 plus what? 0.35, 0.65. 0.65 plus 0.2, 0.85. 0.85 plus 0.15, get 1, which is 100%. So this is called the relative frequency, relative cumulative frequency. Sometimes the measure would be very apart. Unlike these ones, which are 1 to 4, these ones is 1. The highest number is even 14. So we can't do that. We can only but create a range. So the highest number is 14. The smallest number is what? The smallest number is 0.
0.
So in this case, we first need to count the number of elements that we have here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So 5 times 6 is what? 30. So to find the class width, you just simply divide our range divided by what? Number of classes that we're going to have. Now, number of classes, you don't just guess them. We have a formula to use. This formula is given by 2 to the power k should be greater or equal to n. So our n is what? 30. So you need to look at numbers 1, 2, 3, 4, 5, and maybe up to 6. So you need to look for a number that will give you a figure that will exceed this one. So 2 to the power 1 is 2. So it's not exceeding that, so we cancel it. 2 to the power 2 is 4. So this 2 is not giving us a number more than that. 2 to the power 3 is 8. So this 3 is out. 2 to the power 4 is what? 16. So this 4, we can't have 4. We continue. 2 to the power 5 is what? 32. Aha. So this is the number of classes we're going to use. So we divide the range. 14 minus 0 over 5, which is 2.8 to the nearest is 3. So the class width must be 3. So that's the easiest way of finding the class width, which is appropriate. Whenever they say find a suitable width using suitable number of classes, that's what we do. Are we following? So in this case, we're going to say 0, 1, 2. These are in one class because we're talking about 3. So 0 to 2, that is, and we go to 3 to what? 3 to 5, 6 to what? 8. The 3 numbers here. So what you need to understand is 0 to, for you to know the class width of 3, you just 0 add a 3. 3 plus 3, 6. 6 plus 3, 9. 9 plus 3, 12. And here 2 plus 3, 5. 5 plus 3, 8. 8 plus 3, 11. 11 plus 3, 14. I have a problem with people who don't understand classes because they think this is supposed to be 0 to 3. And this will be 4. They added 3 to 7. What they don't know is that in here, the numbers that they're considering is 0, 1, 2, and 3. So this width cannot be 3. So width of 4. Here, we have 4, 5, 6, 7. The width here is not 3, but 4. So you need to be careful that this is an inclusive width that we are talking about. So the easiest and the best way is for you who are laymen, if you have a width of 3, just subtract a 1 there so that you don't get confused at 2. 0 plus 2 is what? 2. Then you go to the next number 3. 3 plus 2, 5. You go to the number 6. 6 plus 2, 8. Or just get the first number 0, then add what? A 3. It's safer like that. So this is how we're getting now. 0 to 2, 3 to 5, 6 to 8, 9 to 11, 12 to 14. Then from there, you manually look for how many numbers are between 0 and 2. I'll not go through that process. You count 0 and 2, 1, 2, okay, 3, 4, 5, 5, 6, okay. That's where the 6 is coming from. In like manner, when we go to assignment here, we were given a data set. So firstly, we're asked to calculate our class width using what? A suitable number of classes. So this was brought to you to test you on that very example. So 1, 2, 3, 4, 5, 6. We have 6. 1, 2, 3, 4, 5, 6, 7. We have 7 there. When you apply 6 times 7, we get what? 42. So firstly, the range is easy to identify because we're getting the highest number minus the smallest number. So you could check literally here to identify which one is the highest number. It is 83. Any number bigger than 83?
87. There's 87 there.
Yeah, 87. There's 7 here. Is there a number bigger than 87?
No.
No,
And the smallest,
it's 7.
the smallest number is what? Is it 22?
22.
Yeah. So on the range, we don't have a problem. How do you find the range? 87 minus 22, what do we get? Okay, now my key interest is our K, the number of classes. How do we identify the K to pick? The formula is 2 to the power K must be greater or equal to what? 42, all right? So you need to have a table of 2 on your own. So have 0, 1, 2, 3, 4, 5, 6. So 2 to the power 0 is 1. 2 to the power 1 is 2. 2 to the power 2 is what? 4. 2 to the power 3 is what? 8. 2 to the power 4 is what? 16. 2 to the power 5 is what? 32. 2 to the power 6 is what? 64. And our n is what? In this case is 42. So which k are we picking there? Which first exceeds this 42? Is it 5? No. And above? No. Is it 6? Yes. So the number of classes we're going to pick is what? 6, because it satisfies our condition. So our range should be what? The difference between the highest value minus the lowest value divided by 6. So 6 is coming from this formula here. So 87 minus 22 over 6, we get 65 over 6 to get 10.83. Approximately 11 classes that we're going to look at. So like I said, in your mind, subtract the 1 so that you're looking at 10, for instance. All right, so starting from the smallest, get the 22 plus 10, 32. Go to the next number. 33 plus 10, 43. Go to the number. 44 plus 10, 54. Next number. 55 plus 10, 65. Next number. 66 plus 10, etc. Then you manually check the frequency. How many are between 22 and 32? There are 4. 4, 9, 14, 6, and 5. Then the relative frequency, 4 out of the total, which is 42, is 2 over 21. 4 out of the total, 2. You can leave it in decimal if you want the relative frequency. You can leave it in decimal. All right. So this is just adding from what I was just teaching, that you understand it fully. Interesting, isn't it?
Yeah.
So this is what was supposed to be done and looked at. All right. Then it takes us to how to come up with ungrouped data. So when you're given ungrouped data, they're asking us to find maybe the measures of central tendency. Okay, so 6, 2, 2, 4, 6, 8. The first thing is to arrange the data in ascending order. 2, 2, 4, 6, 6, 8, 20. So here we're able to identify the range. The range is the difference between the highest number and the smallest number. So 20 minus 2 is equal to 18. The mode is the most frequent number. So the numbers that are appearing the most in this case are 2 and what? 6. It's a bimodal frequency. All right. These are the easiest to identify. Then we have what we call the quartiles. Q1, it's a first quarter, 1/4. Q2, the second quarter, 2/4, which is half. It is also called the median. Then the third quarter is 3/4. So each of these ones, the rule is simply you multiply it to the n and you round up if you get a decimal. 1, 2, 3, 4, 5, 6, 7. So the first one is a quarter of 7. What is a quarter of 7? 1.75. When you round up, it's a second number. So when you go here, 1, 2, so our Q1 is a 2. Our Q2 is half of n. Half of 7 is 3.5. We round up, whether it's 0.1, 3.1. So this is a fourth number here. Already this is our Q1. So we count 1, 2, 3, 4.
Colin, sorry.
Uh-huh.
How did you find, where's the n? N is what?
1, 2, 3, 4, 5, 6, 7. The number.
Oh, okay. Okay, I get it. Okay, thank you.
Yeah. All right. And half of 7. So 7, half of 7 is 3.5. 3.5, you round up the fourth number. So we have the numbers as they are outlined. We have 1, 2, 3, 4, 5, 6, and 7. So the fourth number in this case is what? 6. You put your 6 there. All right. Then you go to Q3, 3/4 of what? Of 7. 3/4 of 7. What is 3/4 of 7? 5.25. Round up, which is what? The sixth number. So the sixth number is 8. So our Q3 is 8. All right, so we have Q1, 2, 6, 8. 2, 6, 8. So in this case, we calculate the box-Whisker plot. The minimum value of x and the maximum value of x. Then we have Q1, Q2, and Q3. So coincidentally, the minimum value of x is actually our Q1, so it is a 2. The minimum value of x. So we can shift there to the 8. To the so Q2 was 6, and our Q3 was what? Q3
8.
8. Okay. So let me draw it again. The box-Whisker plot has 3 key variables. Let me draw it in x min, x max. Minimum value was 2, the maximum was 20. The Q1 was what? 2. Q2 was what? 6. And Q3 was what? 8. Now I push this one here because this is 2 and this is 2 on the number line. So when I push this one, it's as good as the Q1 and the minimum value of x being at the same spot. So I hope you understand what I'm talking about there. Otherwise, this will now take us into what we call grouped data. But group data, we need to also explain how to calculate the mean, the mode, and the standard deviation for ungroup data. So when you have values like 2, 4,
Collins,
yes, sir.
yeah, on the box and whisker,
Mm-hmm.
how can we find outliers?
Okay.
Or you will come back to that
Yes,
later?
I'll come to that, yeah.
Oh, okay.
Mm-hmm. So when you're given value like 2, 4, 6, 8, so when you square this, we're going to get the values of the square here as what? 4, 16, 86, and 64. So you add here summation of x squared. So what's the total here? 20. What's the total here? 120. What is our n? 1, 2, 3, 4. So to find the values of x, it's simply summation of x over n. So our 20 divided by 4 give you a 5. So mean is given by x bar for a population. For a sample, for a population's mu, the formula is simply the same. The sample standard deviation is given by summation of x squared minus value of x to the power 2 over n, everything over n minus 1. So here we have 120 minus 20 to the power 2 divided by 4, everything over 4 minus 1. All right, so 20 squared divided by 4 is 100. So 120 minus 100 divided by 3, it will be 20 over 3, which is 6.67. And at that point, you need to now calculate the square root. So variance is given by s squared. Standard deviation is the square root of the variance. So square root of 6.67 is called standard deviation. So you can go on the calculator and help me identify our 6.67 square root. What do we get?
2.58.
2.58. You can also calculate the coefficient of variation by dividing the standard deviation divided by the mean times 100. What do we get? 2.58 over 5 times 100. 51.6%. So this is what we call the CV. CV stands for the coefficient of variation. Okay. So we also
So,
have,
Colin,
yes,
just before. So in a layman's language, I just want you to explain, if you're explaining to someone who is at the village who doesn't know, how would you explain the mean, standard deviation? I know the mean is average, but are there any other ways, more especially standard deviation, coefficient, variance, and yeah, just these two?
okay. Any other question besides that? Very good question. Want to actualize what these denote, okay, in real life and how applicable they are. So when we are talking about the mean, we are basically looking at the average of data sets. Now these data sets are simply found by totaling up whatever you have and dividing by the number of the data points. So how do we utilize this if we're talking about the village, and people want to understand the importance of the mean? And let me just give you a few notes just to help you. Let me start with the mean. So like I said, the mean basically looks at the average of data sets and is calculated by adding all the values and dividing by the number of the data points that you have. So we use that in central tendency. In real life, for instance, if you have 10 people with different heights, 165, 170, etc. To find the mean height in that household, we add all their heights and divide by 10 people. And we're going to get that on average, this household has that mean height. Also, you could use it to those who are in Chirimba, calculating how much they've put together and the interest they've gathered up, divide by the number of people to know how much each person will get. It's called an average. Packet. Variance basically looks at the measures of spread of the data points around the mean. They quantify how much individuals are deviating from the mean itself. If we have a higher variance, it means that the spread is higher. You are inaccurate, in short. It's an error term. In real life, we want to look at this mean that we found of what? 172.2 of the heights in the villages. So if you subtract the mean from each data point, the variance that we're going to find is about 60.96. It means the degree, the deviations from the actual mean, if we sum them up together, they're coming up to 60.995. All right. So this is how away we are from the mean. Then we go to what we call the standard deviation. Standard deviation is basically the square root of the what? The variance. So this one here is also very important statistical measure, which helps us understand the following. On the variance, the standard deviation will help us also measure the dispersion that we have from the mean. The smaller the standard deviation, the closer we are to the mean. The larger, it means the dispersion is high. So in the data set that we have, we square root 60.96, our standard deviation is 7.8 centimeters, meaning that is our deviation from the mean. And the coefficient of variation basically looks at a percentage or the relative measure of dispersion, which is calculated by the standard deviation divided by the mean. It helps you measure the variability of data sets with different unit points. For instance, the data set that we are looking for in terms of stock between A and B. If you have CV of 2.5 for A and CV of 4.0 for B, if you want to compare these two, you can calculate the coefficient of variation. So in corporate finance, which I'll take you next year, the assumption is that risk is attached to coefficient of variation. The higher, the more volatile that asset is. So you'd rather go depending on the type of investor you are. If you're a risk taker, you go for one with a higher risk, with the presumption that the higher the risk, the higher the returns. Is that clear? Are we on the same page?
Just repeat the last part.
The last part with the coefficient of variation, it helps you compare the relative variability that may exist if you are into investments of stock. You discover that one asset with a higher CV would denote having a higher risk. So the volatility in that asset is higher, is more unstable. So you'd rather choose one with a low volatility. What is volatile is what likely to change, more risky, in short. Volatility in the context of coefficient of variation represents a degree or measure of risk. And so it is a very important measure that is used whenever we are comparing two assets to ascertaining which one has more risk compared to the other. For decision making, to associating yourselves with an asset that may perhaps not make your investment risky. So CV is an important investment too. All right. So
Good. We'll go through when you share the notes.
yeah.
At least I have an idea.
Okay, then we also have what we call a stem and leaf diagram, which has the following nature. For instance, you have 0, 1, 0, 2, 0, 2, 11, 12, 11, 10, 15, 28, 23, 22, 22, 21, 20, 33, 34, 40, 52, 50, 56, 66. So you asked to come up with a stem and leaf diagram for this data set. So you look at the smallest number that we have. In this case, the smallest number is what? Starting with a 0 something. So our 0 is our stem. 0, 1. Then the highest number is a 66. So you just put 1, 2, 3, 4, 5, and 6. Now, for the stem, the procedure is to find the leaf. Just look at the last number that is remaining there. So it's in ascending order. So here we have 0, 1. Then we have 0, 2. The 0 is already here. Then the next number is 0, 2 again. Then we go to the ones, the tens. We have the smallest number 10, which is 1, 0. Then 1, 1. Then 12, 1, 2.
There's another one. There's another 1, 11 there on top.
Another 1, 1. Thank you. Yes. Here then 1, 2. Then 1, 5. 15. Then for the 20s, we have 2, 0. Then 2, 1. Then 2, 2. Then,
Another 2, 2.
then
2, 3.
Then
2, 8.
2, 8. Then the 30s.
3, 3.
Mm-hmm.
And 3, 4.
3, 4. In 40s, there's nothing.
None.
You leave it blank, but it's supposed to be there. 50s, 5, 0,
50.
5, 2.
5, 2, 5, 6.
60s, 6, 6.
6.
So they ask you firstly, find the mode. Mode is the most frequent. So they have these two numbers, this one, and this one here. So the mode is what? 0, 2, 11, and what? 22.
22.
Q1 is half of what? A quarter of what? N.
Yeah.
N is 1, 2, 3, 4. 1, 2, 3, 4, 5. N is what?
20.
So a quarter of 20 is what? 5.
5.
When you find a definite figure, you add the fifth and the second number that precedes it. So it means fifth and the 60th divided by 2. If we found 5.5, we'd have just rounded off to the nearest next number, or 5.1 next nearest number. But if you have a definite figure, you add that in the second figure. So 1, 2, 3, 4, 5, and 6. So what numbers are these? 11 plus 11 divided by 2. What do we get? 11. The same number, just pick it. The Q2 is half of n. What is half of n? Half of 20 is what?
So, just before you go further, Collins, you said when you find a definite number for the first quarter,
you get that very number and the next number and divide by 2. If you find a decimal,
okay,
any decimal, whether it's 10.1, 10.2, you round up. That's the instruction. So here, since we found 10, we're going to find the 10th number and the 11th number. Divide by 2. So you count from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So what numbers are these? 21 and 22. Divided by 2, what do we get? 21.5. And Q3 is 3/4 of what? N. 3/4 of n is 15. So you're going to get 15th number and the 16th number. Divide by what? 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 34 plus what? 33. 34 plus 33 divided by what? 2. It's 33.5. All right. Then the interquartile range is the difference between the highest number and the smallest number on the quartiles. So Q3 minus Q1. That is called our interquartile range. So here we have the 3.5 minus 11. 3.5 minus 11 should be 22.5. So this is our interquartile range. Now, the box whisker plot. We identify the smallest number, x mean, the highest number, x max. So what was our smallest number in this? 0, 1, and 66. So 166. The quarter 1 was what? 11. Here 30 what? 3.5. So the interquartile range, median was 21.5. So interquartile range is what? 22.5. You multiply this one times 1.5, which is a scalar quantity. Interquartile range, what is multiplying by 1.5? 1.5 is a standard. So you subtract it from this angle and you add it to this angle. So the 1.5 will give us what we call the correction term, correcting to identify the outlier. So what is 22.5 times 1.5?
33.75.
33.75. So this 33.75, let's add it to this side first of all. 33.75 plus 33.5, what do we get?
67.25.
67.25. So here, that is the maximum. It's like the first period. So this 66 has survived. If we found 62.75, this could have been outside. It would be called an outlier. Outlier means out of the box. Then now,
Okay.
11, we subtract the 3.75. Let's subtract this side.
What?
So 11 minus the 3.5. So this side we're subtracting, this side we're adding. So we now want to subtract 11 minus the 3.5. We're going to get negative what?
Negative, okay. Negative 22.5.
Negative 22.5. So also this one has survived here. So in this case, there are no what? No outliers.
No outliers. Okay. I see.
So this is how we identify the outlier, whether they're there or not. All right, I've spoken of a lot of things today. I don't want to stuff you with so much.
Yeah, I think let's end here.
Yeah, I have mine. So I'll send you homework just based on what I have done. Thank you so much for your time.
Okay.
Unless I
You'll send the recording
yes,
as
please.
well? Okay.